That was a good night, and a great venue, and a fantastic mixing board. That's a Soundcraft board, and I really liked working on that Soundcraft board. Had a big meter bridge all the way across the front of it, so you had full meters in every channel. And the board had good feel to it, and it was very precise feeling. It was kind of like driving a sports car. I like the Soundcraft boards. They feel really accurate. It's kind of like being in the kitchen with a razor-sharp knife. I also like the Allen Heath boards, which to me had a bit of a heavier feel to them, but equally in control, kind of like driving a Bentley. I've used a whole lot of different analog mixing boards through the 70s, 80s, 90s, early 2000s. And when I got into digital mixing, I picked up a Presonus 2442, which was really the first digital mixer that was affordable enough that local bands, well, if they stretched a little bit, they could get one. And compared to some of the other boards I had, that Presonus was kind of felt like a piece of garbage. But it had features that the analog boards didn't have. And I remember the first time using the digital board, thinking, well, I'll check this out and see how it goes. And next week, we'll be back on the regular system. But I think the first time that I used the digital board was the last time I used the analog boards. As soon as I started mixing digital, it's like, oh, it just opened up a whole world of possibilities. You had effects such as compression and parametric EQs that were really controllable on every single channel. You had the ability to save scenes. You had the ability to export all those tracks to your digital audio workstation. You had the ability to remote control the board from a tablet. And all of this was fantastic. And it meant that I didn't have to carry around a whole bunch of outboard gear. So I'm a real digital guy. Now, I was recently asked to talk about mixing a band in the process of using an analog board and how you hook up all the outbound gear to set up your band using an analog system. And, well, I've done that a lot, so I'm happy to talk to that topic. But as I can tell you earlier, I'm a digital guy. And so once I jumped over to the digital world, I never looked back. And so I know that that's the status that a lot of folks are in, and everything these days is going digital. And so you can find some really compelling deals on used older analog boards, some really nice analog boards that back in the day sold for a whole lot of money, and they're now being sold for dirt cheap. And so my advice is, if you're looking for a mixing board, don't buy an analog board. I think it's dead-end technology, and I think with an analog board, you're then also going to have to carry around a whole bunch of outboard processing gear, and it's just inconvenient, and it doesn't give you the tools that a digital system does. But I know there's still interest in knowing about using analog boards, so we're going to talk about that. I know there are still some sound guys, even some really respected sound guys, who would say that analog boards just have a certain tone characteristic to them, a certain sound quality you just don't get in the digital world. And to them, I would say, well, you might be a better audiophile than me. You might be right. But to me, the digital boards sound just fine. And with all of the other features that come with the digital board, I think it's just compelling. Now, there is one thing about analog boards, which is that they have almost zero latency. So as soon as the signal goes in, the signal comes out. With digital processing, there's always a little tiny bit of delay for that signal to pass through the equipment. And so if you're doing stage monitoring, there is a tiny delay in the signal coming back to the performer. And I've never had anybody complain about it, but there is an argument for using an analog board for your stage monitoring because it has zero latency. Now, when it comes to analog boards, there are differences from one to the other, but they're more alike than they are different. And so Speaking generally, if you can mix on one brand board, you can carry over and mix on another brand board without too much orientation. It's sort of like if you can drive a Chevy, you can probably drive a Ford. Just grab the big wheel and push the pedal and off you go. I was asked to talk a bit about how to operate an analog board and how to connect all the outbound gear to do a typical rock and roll show. Now, I'm going to go through how I did it and how my system is set up. There's more than one way to do things. There's more than one right way to do things, but this is how I did it. So I'm going to talk through how to operate an Allen Heath Mix Wizard, just because I used a Mix Wizard for a lot of shows, and it's a nice little compact board that gave me everything I needed. I preferred mixing on my GL2200 or GL2400 Allen Heath board, but the Mix Wizard was actually very similar, although more compact. And those boards are very similar to each other, and if you're using a different board, well, chances are it'll be pretty darn similar to what I'm going to go through here. Now, I'd love to show it to you. I'd love to actually give you a walkthrough, but unfortunately, since I've been in the digital world for so long, I just don't have any of that gear anymore. So this is going to be a bit of a slideshow presentation where I'm going to show the diagrams of all of the different parts of the mixer, and we'll walk through in kind of a PowerPoint style presentation as to how to run the mixer, how to route the signals, how to connect your outbound gear, and the whole signal flow and process that I used in my sound system for local bands using an analog mixer and outbound processing. Now you'll notice that I have a fair amount of outbound processing. I have a lot of compressors. But don't be daunted by the number of it, because remember, in one single rack space unit, you can get 2 compressors, or maybe 4 compressors. And there are also outbound units that might be 2 or 3 rack spaces that will give you 8 compressors in one unit. So even though I might be specifying that I used a total of 10 compressors in my portable rock and roll PA rig, that's really only a few pieces of gear. And same thing for equalizers. But we'll go through all of that when we get into the outboard gear processing. But at this point, let's talk about the Allen Heath Mix Wizard, and we'll go through the typical signal flow through it and the operation of all of its essential controls. And like I mentioned, you might be using a different analog board, but chances are whatever analog board you're using is going to be pretty darn similar to what I'm discussing here. There might be some minor differences in terms of the number of buses that yours has versus this, or some ancillary features like matrix mixing or perhaps some built-in effects. But we're going to just cover the core part of it and show you how I used to do it. Hey, thanks for watching the video. I appreciate your support. If you haven't subscribed already, it would be cool. I'd like that. And the actions of subscribing, hitting that bell for notifications so you're notified when new content comes down, giving the video a thumbs up, or participating in the comments. All of these things signal to YouTube that they should promote this to more people. So thanks for your support. Let's get back to the video. We're going to do a crash course on how to run an analog mixer and how to hook up all of the equipment that you need to complete your PA system. So get comfortable and we'll begin. Here's the overall view of the Allen Heath Mix Wizard, a fairly typical small format console. As you can see, as with most analog boards, there's a whole bunch of knobs. And undoubtedly, at some point, somebody's going to come up and say, "So, you know what all those knobs do?" Well, if you don't, you will soon. As you can see, it's just a whole bunch of channel strips that are more or less identical. So we're going to take a look at the channel strip and go from top to bottom, and I'll give you a quick run through for all of the controls. on this Allen Heath Mix Wizard. You might be using a different board, but chances are whatever mixer you're using is going to be pretty similar to this one, with much of the same controls, or pretty similar controls. The board is divided into a group of channel strips going from left to right, and each channel strip represents one of the inputs, for example, one of your microphones. So we'll start at the very top of the strip, which is the preamp section. And the first button up there is labeled plus 48 volts, which enables phantom power on that channel. And we would have to turn on phantom power if we have a device connected that needs it. For example, condenser microphones or some active DI boxes make use of phantom power to power the electronics inside of the microphone or that active DI box. This is just a very low energy DC signal that's sent down the mic line to provide power to electronics that are built inside of the microphone. Now, dynamic microphones like your Shure SM58s and 57s and most drum microphones, with the exception of condenser overheads, do not require phantom power. So this is just for condenser microphones or active DI boxes generally. One note of caution is that ribbon microphones could be damaged if phantom power is enabled, but most people aren't using ribbon microphones. Dynamic microphones, such as your typical vocal microphones like a Shure SM58 or instrument microphone like a Shure SM57 or something of that nature, should not be damaged if phantom power is applied. But if there is no need for phantom power, I wouldn't turn it on. The next button below that is the pad button, and that reduces the input signal level so that if you're taking in a high amplitude signal, such as a line level signal, you'll probably want to engage the pad to knock its level down to a usable point for the mixer. Right underneath that, you'll see a gain control, which controls how much gain is in the preamplifier stage for boosting that input signal to a big enough point that you can work with it comfortably. As you turn the gain control clockwise and turn it up, at some point you will overload the mixer, provided that you have some reasonable input signal coming in. And when that channel gets overloaded with signal, there will be a red flashing light which indicates peak that will start to illuminate. On some mixing boards, there's a light right up by that gain control. But on the Mix Wizard, the light is down lower on this channel strip, down by the master fader for that strip, which we'll take a look at in just a moment. And what we want to do is play a little bit of the game of level shuffleboard here, where you want to turn that gain control up just until that red light starts to blink, and then turn it down just a little bit less than that. So we want to get the channel gain as much up as we can, as high as we can, without exceeding the maximum limit where the light starts to blink. So you don't want to see that light blinking in normal operation. That's a warning that you're overloading the channel, and that could result in distortion. And we don't want that because distortion sounds bad. But we also don't want the gain so low that our signal is buried down in the noise, or that we don't have enough signal really to work with and we find ourselves pushing all the faders to the top in order to get something usable. So we want to bring that gain control up as high as we can without having the red light blink on us. Now, once in a blue moon, a couple of really quick, spurious times during the show, if you get a flash out of that red light, it's not a tragic situation, but we don't want those lights blinking overload on any kind of regular basis, because that could indicate poor sound quality as we distort the preamp. The button underneath that, which is labeled HPF, is a high-pass filter, or conversely, a low-cut filter. And so that cuts out all of that deep bass rumble from that channel. Now, if we're dealing with an actual bass instrument, like a bass guitar or a kick drum or a keyboard, which can produce deep bass, we don't want to cut that out. We want to keep that deep bass. But there's a lot of instruments that don't have deep bass content, and cutting out the deep bass only makes them sound cleaner and clearer. For example, your vocal microphones. There's almost no real energy in the vocals below about 80 hertz for most people. And so there's no point in carrying that low frequency energy through the system, because that's just going to pick up room rumble and other extraneous stuff that we really don't want to add to the mix. So if the signal doesn't truly contain deep bass, we want to push that button in and turn on the high pass filter. So you want that filter engaged for things like your vocals, guitars, the drums with the exception of the kick drum or maybe the floor tom, and so on. So that will help you give a cleaner, clearer mix without deep bass rumble. As we move down to the next section of our channel strip, you'll see that we have tone controls. And your mixer's tone controls may be a little different than the Mix Wizard's tone controls, but this is a pretty typical setup. So this is just a bass and treble control, but there's quite a bit of control available in this equalizer section. And one thing to keep in mind is that a few dB of boost or cut, and particularly boost, can represent a big change in the output power level. And so use tone controls sparingly. Use what you need, but don't go overboard with it unless it's really necessary. And if you find yourself needing to use a whole bunch of tone control to get a sound that you like, well, maybe you should take a look at that source. Maybe that instrument just doesn't sound right and you should make some changes there. Maybe you're not using the right microphone for that source, or maybe your microphone placement could be better. So explore those things before just blindly grabbing the old tone control and trying to push the sound around. But the tone control can certainly be used to sweeten up your sound, and the top one is the high frequency or the treble control. Then the next two below that are the high mid-range control. And one of those controls adjusts the actual frequency that you're adjusting. And then the lower one, the third knob down, controls whether or not you're going to boost or cut the frequency that you've dialed in on the second knob down. So you can adjust the frequency and then you can adjust the gain. The next two knobs below that are the low mid-range control. So you can, again, adjust the exact frequency that it takes action at, and then the knob underneath that, the fifth knob down, controls whether or not we're boosting or cutting that low mid-range tone. And then the very bottom knob is the low frequencies or the bass control. And so all of these things allow you to do tone shaping for whatever instrument is on that particular channel. Now there's a button underneath it called EQ In, which enables or disables those tone controls. So if the button is out, you get completely flat response with no adjustment whatsoever, and it's just a pure signal coming straight through the mixer. If you push the EQ In button, then those tone controls take effect and you can sweeten the sound. Now, some mixers, when you adjust the tone controls, adjust the tone of that channel for everything and everywhere that signal goes to. So if you adjust the tone controls, it also adjusts the tone of that instrument as it's folded back to the performers on stage through their monitors, as well as adjusting it for the front of house speakers. Some other mixing boards, or depending upon how the mixing board is strapped up internally, some have some jumpers on the circuit board, will only adjust the tone for what's coming out to the main speakers, the front of house, but do not make tone adjustments to the monitor speakers that the musicians are hearing. Most of the time, this tone control will affect everything. And if that's the case, be aware that as you're changing these tone controls around, you're also changing the mix that the musicians are hearing while you're doing it. And if you've carefully wrung out those speakers for feedback on stage, as you adjust these tone controls, that may disturb the anti-feedback equalization profile you've dialed up. So for example, if you decide to do a radical boost in the high end on these tone controls, that just might be a cause of feedback on stage with your stage monitors. So use caution there and be aware of that. In the section below the equalization section, you see that we have 6 controls for the auxiliary outputs, labeled auxiliary 1 through auxiliary 6. The top 2 controls are defined as pre-fader. The next 2 can be selected pre or post fader, and the bottom 2 are post fader. And what that means is the signal comes in from the top of that channel, and if it's pre-fader, it goes directly through these controls and to the output buses associated with that control, the auxiliary 1 or 2 or 3 or 4 bus, for example. If the switches are set to post fader, or if we're dealing with auxiliary 5 or 6, which is always wired up as post fader, the signal from this channel first goes down to the big fader at the bottom, the sliding lever that goes up and down, the big fader. And so it goes there first, and then it comes out of that fader and then into these buses. So if you have the big fader at the bottom of the board turned all the way down to 0, there's no signal, and there's no signal that's going to go out of any of these auxiliary buses. But if the big fader is turned up, then there's signal available, and it will go out the main speakers, and it will also be available to go out these buses if these buses are turned up. Okay, so the way I would normally have the board set up is I would set up channels 3 and 4 to be pre-fader, that is the square button pushed in. So that means that auxiliary bus 1, 2, 3, and 4 are all set up as pre-fader. So the output to those buses on the back of the board, 1, 2, 3, and 4, have no impact at all, or are not impacted at all, regardless of whatever the fader position is that is driving the signal to your main outputs, to your front of house. And those 4 channels, auxiliary 1, 2, 3, and 4, are used for the musician monitoring, the fold-back stage monitors that the musicians listen to. And so if I want to send some of this microphone to monitor 1 on the stage, I just turn up auxiliary 1, and that will send some of this microphone signal to that speaker. And likewise, if I want to send it to auxiliary 2, it goes to its speaker and so forth. For sanity reasons, I would typically have my monitor 1 be my far left monitor on stage. Monitor 2 would be at the center of the stage. Monitor 3 would be on the right-hand side of the stage as viewed by me in the audience. And monitor 4 would be the monitor that the drummer listens to. Now, of course, it doesn't matter what kind of stage monitoring you're doing. These could be in-ears, or these could be monitor wedge speakers. But in any case, those are your 4 musicians' stage monitors. And we want them to be pre-fader. So as we're pushing the fader at the bottom of the board to turn this channel up or down in front of house for the audience, we don't want those levels to be shifting around for our musicians on stage. We want that to be consistent. So that's why these are set up as pre-fader. Now we have auxiliary 5 and 6, and those are set up as post-fader. So we can use these controls to send some signal out to the buses 5 and 6, but they are dependent upon how loud we have the fader down at the bottom of the board pushed up. I would use channel 5, auxiliary 5, as a send to my vocal effect processing. So I have a rack mount device that offers reverb or echo type effect, and this is the amount of signal I push from this microphone into that device. And I want that to be post fader. So as I turn up that vocal in front of house, its effects also come up with it. Or conversely, if I turn the vocal down, it also turns the effects that are associated with those vocals down the same amount. If it was pre-fader, you could turn the vocals all the way down, but you'd still hear the echo effect, and that wouldn't be good. Channel 6 I used for low frequency output, that is the subwoofer output. So I would set up the system so that none of the microphones or instrument inputs go to the subwoofer at all, unless I turn up the knob auxiliary 6, and that then sends a signal feed from this microphone or this input source into the amplifier that drives the subwoofers. Now, it's also going to left and right mains as well, but by doing this, all of the instruments that don't require any subwoofer support, for example, your vocals, lead guitar, the higher frequency parts of the drum kit, with the exception of floor tom and kick drum, none of those things have any real low frequency output that's important. And so there's no point in sending any of that signal to the subwoofer system, because all that's going to do is pick up noise in the room and other low frequency stuff that we really don't want and send it out to the subwoofers to make a more muddy band sound. So by completely cutting out any signal path from the vocal microphones or from lead guitar and so forth to the subwoofer system, there's no way you can feed anything from those channels to the subwoofer system. It ends up being a cleaner, clear band mix. The bottom part of the channel strip is primarily occupied by the channel's fader, the big fader that you slide up and down to control the amount of that channel that goes out into your front of house speakers. And so by adjusting these faders relative to each other, you can adjust the mix of the band. Now at the very top of this section, you'll see the pan control. So that adjusts how much of the signal goes to your left speaker versus your right speaker. And by adjusting pan, you can set up a stereo sound spread as you desire. I almost always set up everything as straight up mono because I don't want a whole lot of content going to one side of the venue and not the other, because I know that there are people spread out all around the audience on both the left and the right side, and I want to make sure that everybody can hear all of the instruments. I don't want really radical stereo spread that puts the guitar on just one side of the room while the people on the other side of the room suffer with poor sound. One exception to that is my vocal effect processor. Typically, I would send a mono signal into the effect processor, but I would get a return from it, which is stereo, which gives a nice wide sound spectrum for the vocal effects, and I would run that as a stereo mix coming into the mixing board. And so that gives a big lush sounding vocal with some three-dimensionality to it. Right below the pan control is a button labeled mute, which kills that channel signal. And so if the band is going to take a break, you can just tap the mute button and that turns off the channel so you don't get any noise coming through the channel that's unwanted. Or if there's a channel that isn't being used for a particular song, for example, a vocal channel which is not used on a particular song, I would hit mute just to reduce the amount of input of noise from that microphone picking up things in the background. And so the fewer channels that are active at a time, the cleaner the mix is that you're going to get. Typically, when you hit the mute button, there's a red light or an indicator that illuminates, letting you know that that channel is in a muted status. Underneath that, you'll see a small LED light, which is the overload light for that channel, and it might also be used for other signaling depending upon the board. But if that light is flashing, that means that the signal level on that channel is too high, and you're risking getting into the area of distortion. And so if you see that light blinking occasionally, that's an indication that you probably should reach to the very top of the channel strip where the gain control is and turn it down just enough so that the light doesn't blink. Then there's a button labeled PFL, which is Pre-Fader Listen. And oftentimes when you push that button, an indicator will appear on the channel indicating that you're in that mode. And what that does is on the headphone output of the mixing board, where you can monitor what's going on, it turns off everything to your headphone monitors except for this channel, or the channels that are pushed up into PFL mode. So if you're listening on headphones and you're listening to the mix coming through and you want to zero in on what a particular channel is doing or sounding like, you can push PFL and it will mute everything on the mixing board in your headphones except for this particular channel. And then below that we have the fader for that channel, which if you bring it all the way to the bottom will kill the signal to front of house, and so nothing will come through. As you push it up, the signal gets louder, and if you've got your gains all set correctly, typically your fader should be running somewhere around the 0 mark for decent signal coming through that channel. In the world of mixing a band, you might have some channels that are pushed up higher and some that are lower, depending upon the mix that you're trying to achieve. So I'm not saying that there's any position that the control really should be at. You know, that all depends upon your artistic expression of the mix. But generally speaking, I would expect to see those controls somewhere around 0, plus or minus a little bit, if you have the gains scaled and set correctly. So now that we've covered the channel strips, let's slide over to the right-hand side of the board where all of the output controls are. So nearing the right-hand side, you'll see this group of controls, which are the master outputs for those auxiliary feeds numbered 1 through 6. As you recall, we had all those auxiliary feeds on each of the channels for how much we drive that channel into one of the auxiliary buses, and then these controls control the overall level of those auxiliary buses getting sent out to your devices. And so numbers 1, 2, 3, and 4 would control the amount of volume that goes to each musician's stage monitor. And if it's a speaker on stage and you turn this up too much, you risk feedback. And so with controls 1, 2, 3, and 4, you can control how loud each monitor on stage will be. Number 5 is the control that is used to send signal to your vocal effect processor. And so you're going to turn up number 5 until you see a reasonable signal level at your vocal processor. It usually has a meter on it, and so you want those signals to be close to 0 dB, but not exceeding 0 dB on your effect processor. So you adjust number 5 accordingly. Number 6 is the feed that goes to the subwoofer system in the front of house. And so you're going to turn that up to drive the subwoofer system. And you can turn it up more if you want more bass, or turn it down if you want a little bit less. On the far right of the Mix Wizard, you'll see the output meters, and those meters will be bouncing around as you're sending signal out to the main left and right loudspeakers. If you're way up in the red, you risk distortion, and you'll probably have ear-splitting level in the house if you have your gain set up reasonably and all of your pieces of equipment. There's no right level on these meters. It just gives you an indication as to how hard you're pushing the system. At many of my shows, I would be down at minus 15 or near the bottom of the meters because that's all that I needed in order to fill that room with an adequate level of sound. So it gives you some indication as to how much headroom you have available in the system. Underneath the meters, you'll see a light for power, meaning that the mixing board is plugged in and turned on, and hopefully that light is illuminated while you're mixing the band. Otherwise, things tend to be pretty quiet. Underneath that indicator is a indicator called PFL for Pre-Fader Listen, and that will be illuminated if one of the PFL buttons on a channel strip is depressed, and it indicates to you that what you're hearing in your headphone feed from the mixer is just that channel, or whichever channels have been selected in PFL mode. If no channels are up in PFL mode, that indicator will be extinguished and you will be listening to the program in the headphones, typically the left and right bus mix. On the Mix Wizard, there's a sequence of push buttons underneath the headphone volume control, which is the next control that you see with the headphone indicator by it. And all of these push buttons will let you listen to the auxiliary buses. Those are the buses that are feeding your stage monitors or other external devices. Typically, I would have that set to the main left and right outputs. But those buttons allow you to listen to all the different outputs that are happening on the board, so you can select what you'd like to listen to in your headphones. At the very bottom of the right-hand side on the Mix Wizard are the main output faders. And these are the faders that control how loud the speakers in front of house are driven. And you'll see on the very rightmost fader above it, there's a button that controls its operation. That fader is labeled mono or center. And with the button in one position, the output of that channel is a summation of the left and right. So you get left and right and a mono output, which are all essentially the same group of signals. On the other hand, if you enable the button at the top of that farmost right control, then it becomes attached to bus feed number 6, which I use for my subwoofer output. And so that gives me left and right and subwoofer. So left and right control would be controlling the amount of signal that goes to my mid-range and high-frequency speakers in the front of house. And the far right control controls how much drive I put into the subwoofer system. So if I want to turn up the overall level of the band, I push all 3 faders up for the mid-range and high-end and the subwoofers. On the other hand, if I just want a little bit more bass, I can push up that control on the far right, which is running the subwoofers. Or if I want a little bit less bass, I can pull that one down. So that gives you a real easy way to control the general balance of the high frequencies versus the subwoofers right on these controls right there. And it makes it easy to turn up all of those parts of the spectrum at the same time if you want to, by just simply sliding all 3 of those controls up or down as a group. Now let's take a look at the back of the Mix Wizard. On the back, you'll see that there are input groups for each of the input channels. And this mixer has 16 inputs, so you'll see 16 of these groups of connectors. If we take a look at this group of connectors, the first one is labeled Insert. And this is a place where you can break the signal on that channel, send it out to an outboard processor, and then return it back into the channel. And so this is a place where you can insert processing such as compression, or possibly an external equalizer, or any kind of rack mount effect you want to apply to this particular input channel or this particular microphone. If nothing is attached to the insert connector, then the signal flows from the preamplifier section at the very top of the channel on down into the equalizer section and so forth on through that channel. If you insert a cable into that jack, then the signal comes from the preamplifier section of that channel and it gets sent out that jack to be processed by some external piece of gear and then returned back into the mixer for further processing. Then below that, we have a line in connector and a microphone in connector. So if you have a line level signal, you can plug it in directly at that point. And both of these connectors on this mixer are balanced connections. So they're expecting a tip ring sleeve 1/4 inch connector into the line in. It would be unusual to use both the line in and the XLR 3-pin microphone connector. So you would use one or the other, depending upon your signal source. These are both low impedance balanced connections, so you couldn't connect a guitar directly into the line-in jack. You'd have to use a direct input box to make the signal appropriate for going into the mixer. Then at the very bottom, you'll see a direct output for that individual channel. So this is a signal output that is line level, that is the result of the processing in that channel. So if you make equalization changes, they'll be reflected at the line output. Generally, I didn't use the direct out connections unless I was doing something like a recording for the band and I was needing a place to tap the signal for each of these channels. But in normal operations, I would leave those disconnected. Here is an electrical schematic rendition of the insert jack that we just mentioned. As you can see, when no plug is inserted, the tip and ring connections are tied together internally inside of the mixing board. So the signal comes into that connector and gets passed right on through back into the board and passed on to the equalization section of the channel. But if you insert a plug into that jack, then it disconnects that internal connection and routes the signal to your device and back again into the channel. Here is a further depiction of the insert operation. As you can see, the connector on the mixing board is a tip ring sleeve connector, with the sleeve as ground. The ring is a return signal back into the board, and the tip is the signal from the preamplifier of the board that gets sent out to your outbound gear to be processed. On the other end of the insert cable that you would plug into the board, it splits to a Y with 2 1/4-inch plugs on it, which are tip sleeve. These are unbalanced connections, with one of them going to your external processor's input and the other one going to the external processor's output. So you're going to be using a Y-type cable for inserting a processor into the insert connector for a particular mixing board channel. Here's a photograph showing one of those insert cables. As you can see, on the lower part of the photograph, we have a tip ring sleeve 3-conductor connector, which would be plugged into the mixing board. And that goes out to a Y configuration with a pair of unbalanced tip sleeve connectors, which would go into the input and the output of whatever processor you want to patch into that channel. Now, this is a very short cable. In practice, my cables are about 6 feet long, so give yourself enough cable to reach from the mixer down to wherever your processing is. You need to make sure that you get the signal output from the mixing board into the input jack of your external processor, and the output jack of the external processor has to go to the other connector. If you get those guys swapped around, you're not going to get signal flow, and that channel will have nothing happening on it. As we move along the back panel, beyond all of the channel input groups, you'll see this group of connectors, which are the outputs for those auxiliary buses 1 through 6. And so numbers 1, 2, 3, and 4 are output signals that would go to the processing, which eventually goes to the amplifiers which drive the stage monitors. Auxiliary 5 is an output that would be sent into your vocal processor. So that would go to the input of your digital reverb box, for example. Auxiliary 6 is the subwoofer output channel. The way that the board is set up, I wouldn't plug my subwoofers into this output because we have that left, right, center control. And so that's the output that I would use to actually drive the subwoofer system. So in practice, in my setup, the auxiliary 6 output would be left open. And then moving to the edge of the panel, we have one more group of outputs, which are the main outputs for your left and right output. And those 3-pin XLR connectors at the very bottom are the outputs that go to your left and right main speakers. So in my system, those outputs would go into external processing and then onward to the amplifiers that drive the mid-range and high-frequency speakers. The one that's labeled M is the mono output, but as I mentioned earlier, by pushing the button by that control, we patch that over to auxiliary number 6, which is used to drive our subwoofer system. So the output from M on the 3-pin XLR connector goes into the processors that eventually drive our subwoofer loudspeakers for front of house. The A and B outputs up above is an auxiliary set of outputs that the mixing board provides that you can use to drive control room speakers or other things. For my use with live sound, I didn't use those outputs. You'll also see above left and right outputs a 1/4-inch jack labeled insert, and these inserts are just like the inserts on each of the input channels, where if you wanted to, you could use an insert type Y cable to patch in an external processor at that point. Well, we've covered all of the essential features of the mixer, all of its essential controls and inputs and outputs. One of the things that we talked about a fair amount was the insertion of external processing on channels with the insert jacks. Now, the processing that I would most commonly employ in that position would be either a compressor or a gate. And many compressors have gates as part of the compressor as a feature. Compressors control the amount of dynamics. So if you have an input that is highly dynamic, for example, a singer who doesn't stay right on mic, sometimes they're right on top of the mic and sometimes they're back a little bit, or they have a very dramatic style that is perhaps a little bit much, you can apply a compressor to keep the loud sounds from getting too loud and the quiet sounds from getting too quiet. And the compressor will gently ride gain in that channel to provide a consistent level coming out. If you were to set ratio on the compressor for 3:1, that would mean that every 3 dB of input change, the compressor will ride gain so that you only get 1 dB of output change. Or, on the other hand, if you had 6 dB of input change, then you'd only get 2 dB of output change. Compressors can be useful on bass guitars to smooth out the bass so you get a nice, thick, solid foundation to build a mix upon, and that different notes of the bass guitar all come out at roughly the same level. They can be useful on lead guitars sometimes if the guitar player has big shifts in level when they go from one patch to another. And it can be useful on singers if they have any issues with dynamic control or mic handling. I did another video all about operating compressors and the various compressor settings for different applications, so you might want to take a look at that for more information about compressors. Another effect that we might plug into a channel's insert would be a gate. Many compressors have a gate feature in them, or there are just gates that you can apply to the channel. And a gate allows the signal to either pass through or not, depending upon its signal level. So if the signal is very quiet, the gate is closed and it mutes the channel. But once the signal gets to a certain level, which is adjustable by its threshold, then the gate pops open and allows the signal to come through. And then once the signal gets quiet again, the gate closes and mutes the channel. So this can be helpful to automatically mute microphones that are not in use at a particular time. Sometimes gates are used on drums in order to cut out the ringing tail after a drum hit to yield a very hard and punchy drum sound. One thing to be aware of is if you use gates on vocals, it's probably a good idea to let the musicians know that the vocals are gated, so that they have to speak up with some gusto to make sure that they deliver enough signal to break through the gate. And if they just talk quietly into the microphone or mumble a little bit, it's not going to be loud enough to release the gate and let that signal come through. And when you're applying an effect into the insert of a channel, it affects everything, not just front of house, but also what the musicians themselves hear on stage. And so if they're talking quietly into the microphone and barely getting that gate to trip open, they will hear their microphones getting turned on and off by the gate through their stage monitors, and that can be kind of disconcerting. Here is the signal path for driving your stage monitors. This equipment is attached to the auxiliary number 1 through 4 outputs on the mixing board. So replicate this diagram 4 times. Coming out of the auxiliary output from the mixing board, the signal goes into a 31-band EQ. The output of that equalizer goes to a power amplifier, and the output of the power amplifier then goes to your stage monitor. Now, if you're using powered stage monitors, you could plug that monitor directly into the output of the equalizer. The reason for the equalizer is so that if there is feedback that occurs, you can use the equalizer to cut those frequencies where the system is prone to feedback to give you a little bit more gain before feedback happens. Replicate this diagram 4 times, 1 for each of your stage monitors, and they would be attached to the auxiliary outputs 1, 2, 3, and 4. Auxiliary 5 on the mixing board goes to an effect processor for your vocals. So you connect a line from the auxiliary 5 output to the input of your digital reverb box. The output of the digital reverb box then gets sent into 2 available channels in the mixing board, or an open stereo input channel on the mixing board. So by adjusting the amount of level on that channel, you can control how much reverb you get in the mix. Now, because auxiliary 5 is set up on the mixing board as post fader, as you turn up the vocal level, that also turns up the amount of drive going into the reverb. So the amount of reverb and the amount of vocals, that ratio will remain consistent as you turn the vocals up or down. Auxiliary 6 output goes to our subwoofer, and you could tap that signal either from the auxiliary 6 jack on the back of the Mix Wizard, or in the way that we had talked about setting it up, you would actually pick up this signal off of the mono XLR main output. That would go into a 31-band EQ, which allows for some tone shaping of the subwoofer system. Optionally, the output of the EQ could go into the input of a compressor, and then that compressor output would go to the crossover. Or you could skip the compressor and go directly from the EQ into a crossover if you don't feel like compression and limiting is really necessary on this feed. We go into a crossover, and this crossover is used only for the subwoofer system. So in this configuration, you actually have 2 electronic crossovers. This is the subwoofer crossover, so we are not attaching anything to the outputs of that crossover for the mid-range output or the high-frequency output. We're only going to use the low-frequency output, so the only thing that comes out of this crossover is the low-frequency component. All of the highs get rolled off and filtered out. Those lows then go into your subwoofer power amplifier, and the amplifier then drives your subwoofers. Now, you may be using an amplifier that contains digital signal processing, DSP, which gives you crossover and equalization features. And if that's the case, you could forego using the crossover and or the 31-band EQ if your amplifier already provides those features. Alternatively, you might be using a powered subwoofer, and a powered subwoofer is going to include the amplifier unit inside of it along with all of the necessary crossover components. So in that case, you could just have a 31-band EQ that then drives your powered subwoofer. Or you might even forgo the 31-band EQ if you believe the powered subwoofer has its own tone shaping and it works well. So that is the signal flow from the auxiliary 6 output, or in the case of the Mix Wizard, the mono main bus output to your subwoofer system. This setup is referred to as Aux-Fed subs, since we're feeding our subs off of an auxiliary bus rather than just allowing the main left and right to feed the subs. This is the signal flow for your main front of house left and right outputs. So there's going to be two of these implementations in your system, one for left channel and one for right channel. So we come out of the channel and go into a 31 band equalizer so we can adjust the tone shaping of the front of house. Then we go into a compressor limiter, so the output of the equalizer goes to the input of a compressor limiter, and then the output of that compressor limiter goes into a crossover unit. And I've got specified here a three-way crossover, but we've already handled the subwoofers separately, so we're not attaching anything to the output of that crossover for the low frequency side. That's already been taken care of. So we're only attaching connections to the mid-frequency and the high-frequency outputs of our crossover. And the mid-frequency output then goes to a power amp, which drives your mid-frequency drivers, that is 100 hertz to wherever your horn begins, about 2 kilohertz. And then the high frequency output of your crossover goes to another power amplifier, which is then connected to drive the horns in your system. Now, in the event that you're not using a three-way system and you're just driving a signal to your subwoofers and another signal to your top speakers, and the top speakers take care of the whole frequency spectrum, in that case you would just connect your top speakers to probably the high output of this crossover and set its lowest operating frequency to be about 100 hertz. You might be using something such as an DBX drive rack, which is an electronic crossover that also includes the equalizer functionality and the limiting functionality, so you can get all of these components in one box. You might be using a powered loudspeaker, which provides all of the amplifiers and crossover abilities right in that box. So if you're using powered loudspeakers, all you would do is take the output from the mixing board into a 31 band EQ, and the output of your 31 band EQ then goes into the powered loudspeaker. The purpose of the compressor here is for a bit of system protection. The way I normally have it set up is to act as a pretty aggressive compressor on the edge of limiting. So that means a ratio of probably around 10 to 1. So 10 dB of signal change only allows for 1 dB of output shift. I would set the threshold of that compressor to start kicking in only when you start pushing the PA system pretty hard, maybe 10 dB below your maximum output. And so the idea is that for most normal shows at normal levels, you're just barely starting to get that compressor to have any action. So basically it totally stays out of your way until things start getting pushed pretty hard. But then once you start pushing the system real hard, then it starts stepping on the level and preventing much more output from coming through very easily. So this provides a bit of a cushion of protection against large transients coming through the system, or people getting too overzealous at the mixing board and pushing things too hard.
Well, I hope you found that entertaining and hopefully informative. Like I mentioned earlier, there's more than one way you can hook things up, and this is the way that I did it. If you do it differently and you're getting the results you want, hey, I'd call that a success. So, I hope you enjoyed the video. I hope you enjoy the content enough to subscribe to the channel, and I'm looking forward to seeing you again soon on another upcoming episode. Thanks for tuning in.